The Revolve is another type of sketch-based feature that allows you to create geometry around an axis. Take a look at this part here. If I expand the Revolve feature, you can see the profile that was used to create this feature. If I edit the sketch, you can see that this is just a 2D sketch of a circle with a center line that was used for the axis. Before creating a revolved feature, be sure to spend some time thinking about what cross-sectional shape you would like to achieve. Let me switch over to a blank part file that I've already created. We'll be using a Revolve feature to create a wheel part. I'll start by creating a new sketch on the front plane. Anytime I start a sketch with the Revolve feature, I always begin with the center line, which will become the axis of revolution. This isn't required, but it's something I find helps when creating these types of features. I'll expand the line tool and select the center line option. I'll click directly on the origin to add a coincident relationship and make sure that the center line is perfectly horizontal, so that our axis of revolution will be horizontal. Next, I'll switch to the rectangle tool from the shortcut toolbar using the S key, and I will select a corner rectangle. I'll choose my first point here and connect the other point to the center line. I'll create one more rectangle to get the overall shape that we'll be creating, and press Escape on the keyboard to deactivate the line tool. Now I don't need these line segments in the center, so I'll trim them away using the Power Trim tool. We haven't yet covered the Power Trim tool in this course, and I won't spend too long on the feature here, but to use this Power Trim option, all you have to do is click and hold down the mouse button and select the items that you would like to trim away. Once completed, release the mouse button and simply click the green check to finish the trim. Now at this point, we can begin giving the sketch some relations and dimensions. If I click and move the line segments, you can see they are completely free to move right now. The axis of revolution goes directly through the origin. In addition to this, I'd also like some symmetry between the left and right halves of this profile. To accomplish this, I'll sketch another center line. I'll click on the origin for the initial endpoint and drag it up to reveal the midpoint of this horizontal line where I'll choose the second endpoint. To ensure that the center line is vertical, which you can see is not the case here, I'll click on the center line and then give it a vertical relationship. That centers this line segment here, leaving me to just add some symmetry between these two line segments here. I'll hold Control and select this line segment, the center line, and this third line segment here. When I do, the pop-up menu appears where I will select the symmetric relation. At this point, I have all the relations I need, and I can simply add a few dimensions. I'll press the S key on the keyboard to bring up the Smart Dimension tool, and click on these two vertical line segments here to give a width value. I'll type in 35 millimeters and press Enter on the keyboard. Then I'll repeat the process for these outer line segments here, which will be 60 millimeters. Finally, I'll give a vertical dimension here in order to make the remaining line segments fully defined. One thing to note is that since I'm creating a Revolve feature, I'm creating dimensions that are in relation to the axis of revolution. This is the center of the part, and typically isn't how you would want to dimension for inspection or manufacturing, since this part would not be correctly dimensioned. As a result, you can see that when you move your pointer across the center line, SOLIDWORKS actually extends the dimension to become what would be the equivalent of a diameter dimension. Again, if I move it up above the center line, you can see that it's the normal distance, but since this is to the center line, once I move it across, SOLIDWORKS extends it to a virtual point there. So here, I'll type in 50 millimeters and press Enter, and I'll repeat it for this final line segment. I'll click on it and SOLIDWORKS automatically picks up that center line, so I can click again to position the dimension. I'll type in 90 millimeters, press Enter, and at this point, you can see the entire sketch turns black and the status bar tells me it's fully defined. So at this point, I can move on and create the Revolve feature. To do this, I'll switch to the Features toolbar, click the Revolve Boss Base icon, and the Revolve Property Manager appears. In the highlighted box here, SOLIDWORKS prompts us to select the axis of revolution. In this case, I'd like to select the center line that I had sketched, but you could really click on any line segment. With this window active, notice if I click the vertical line segment here, we end up with this shape. This isn't the correct selection, so I'll right-click here, clear the selections, and again, click on the center line. As you can see, there aren't many options in the Revolve Property Manager. As you've seen already in the Extrude lesson, there's a blind option. And since we're revolving around an axis, instead of a distance value, we are instead given an angle. I can type in a value here, press Enter, and you can see how SOLIDWORKS is responding. Just like you've seen with the Extrude feature, there are other end conditions that you can choose, such as up to vertex, up to surface, offset, and mid-plane. If I select mid-plane, you can see that SOLIDWORKS is revolving the feature equally on both sides of the sketch plane. Again, there's a drag handle here so you can move the geometry to see how it updates. But in this case, I'm going to switch back to blind, type in 360 degrees, and click the green check. At this point, we have most of the geometry that we're looking for. In the final part, this is going to have a hole that passes through and some fillets to break all of the sharp edges. These could all certainly be accomplished with additional features, but for the sake of this example, I'll show you how we can accomplish this inside of a single Revolve feature. To do this, I need to edit the sketch, or in other words, the profile that we used to create this. So I'll click on the feature and click Edit Sketch. I'll hit Spacebar and select the Normal to View so we're looking straight on to the sketch. And I will begin by breaking all the sharp edges of the part. I can do this using the Sketch Fillet feature. I'll click the Sketch Fillet icon from the toolbar, and SOLIDWORKS prompts me to select the entities to fillet, as well as the fillet radius under the Parameters box. I'll type in 5 millimeters for the radius, and I can either click on individual line segments, or I can click on the point where the intersection occurs. When I select this endpoint here, SOLIDWORKS warns me that there are some geometric relations on this line segment, and if we round off this corner, the geometry may have to be moved in order to satisfy this relation when the fillet is created. In this case, it's talking about the center line that we sketched to the midpoint of this horizontal line segment. I'll go ahead and click Yes to continue to see what happens. As you can see, when the fillet is created, this line segment would actually appear shorter on the left side than it does on the right side. SOLIDWORKS takes care of this for you and actually extends this out to a virtual endpoint here so that this midpoint relation will be unaffected. To finish up, I'll simply box select these remaining points here, and I get the same warning about the sketch relations. I'll again click Yes to continue, and now all of the sketch fillets are added in the preview, so I can click the green check to update the geometry. When I do, you can see that a lot of sketch relation flags appear. This is because the sketch fillet adds equal relations to all of the fillets that you create, along with an equal dimension value that you see here. This is convenient because if this radius needs to change, I can just change this one here, and all the sketch fillets would update at the same time. So now that we've broken the sharp edges, let's take care of adding the hole. Remember, the sketch is being revolved around this axis of revolution here. So in order to create a circle for the hole, I simply need to move this sketch line up a very small distance. Notice this endpoint of the line segment has a coincident relationship between the line segment and the center line. In order to move this line segment up, I must click on this relation flag and delete the existing coincident relation. Once the horizontal line turns blue, I know that this is not fully defined, and I can move it. I'll give it a new vertical dimension by pressing the S key on the keyboard to launch the Smart Dimension tool, and when I click on the horizontal line and the center line, I can move my pointer across it to create a diameter distance dimension. I'll type in 25 millimeters and press Enter. At this point, when I exit out of the sketch, you can see the model rebuilds. All the sharp edges are broken from our sketch fillet, and you can see that a hole was created by moving the existing horizontal line segment up above the axis of revolution.